Hello, a very good evening to all of you. I hope all of you are doing well. So in today's class, we are going to learn about various components of microprocessor in brief. So as we have learned in the previous class that a microprocessor is a multi-purpose, programmable, clock-driven, register-based computational engine that is capable of performing arithmetic and logical operation. But in order to enable a microprocessor perform its operation, we need collaborative effort of allied units. In the units such as input unit, output unit, and memory unit. Now, input unit is a unit that is responsible for communicating instruction and data from the environment to the microprocessor. Likewise, output unit is a unit that is capable of communicating output values from the microprocessor to the environment back. Memory unit is a unit that is responsible for hosting data and instruction whenever a microprocessor performs an operation. So at entirety, all of these units along with the microprocessor forms the physical component of system and are called as hardware. Now, with each and every microprocessor, there is a set of well-defined instructions associated using which what we can do is we can write programs for attaining a said objective. Now, a collection of program or a group of program is called as a software. Now, this is a basic distinction between a hardware and a software. Now, let us move on to microprocessor applications. So, microprocessor applications are basically classified into two primary categories. The categories are reprogrammable system and embedded system. Now, in reprogrammable systems such as microcomputer, the microprocessor is used for performing computing and data processing, as in case of personal computer. Here, as and when a microprocessor is expected to deliver a said result, microprocessor can be reprogrammed and operate and can be made to perform the desired operation. But in case of embedded system, the microprocessor forms the part of the system. So as microprocessor forms the part of the final product, it is not available for reprogramming. So the basic distinction between reprogrammable system and embedded system is that in case of reprogrammable system, microprocessor is available for reprogramming, whereas in case of embedded system, microprocessor is not available for reprogramming. Now, the fact that the microprocessor is programmable, it basically implies that a microprocessor can be instructed to perform a desired task defined within the capabilities of the microprocessor. Now, whenever a microprocessor performs an operation, it performs the operation using instructions and data byte that is stored in storage device called as computer's memory. So every time whenever a microprocessor is expected to perform an operation, it performs read operation of the instructions and the data and performs the operation. Now, microprocessor always operates on binary digits 0 and 1, and these binary digits are called as bits. And bit is an abbreviation of binary digits. These are basically representation of electrical signals. So each and every microprocessor recognizes and processes a group of bits. Now, this group of bits is referred to as a word. Now, each and every microprocessor are classified according to their word length. So with each and every microprocessor, there is a group of bits that is associated that is called as word, and microprocessor often classified according to their word length. Now, the word length can be 4-bit, it can be 8-bit, it can be 16-bit, it can be 32-bit, and it can be 64-bit. It determines, or it refers to the number of, the volume of information that the microprocessor processes per unit time. Now, let's try to create a distinction between a microprocessor and a microcomputer. Now, a microprocessor always forms the part of many product, but microprocessor cannot work on itself or cannot perform operation on itself. So it requires aid of the other allied units such as input unit, memory unit, and output unit. Along with it requires external power supply. Now, let us try to understand what is a microcomputer. Very often it so happens that microprocessor and microcomputer or computer is used in the same context, but it has a different meaning. Microprocessor often refers to an integrated circuit which has the ability of processing data and along with the control unit and associated register, whereas a microcomputer is a complete computing system built around a microprocessor. That means a microprocessor along with its allied devices forms the microcomputer. Now let us try to understand what determines the capability of the microprocessor, or what is the power of a microprocessor. Now, there are three important measures on which the capability or the power of the microprocessor depends on. The first factor that governs the power of the microprocessor or capability of the microprocessor is the length of the microprocessor's word. So, greater the length of the microprocessor's word, greater will be the volume of data that the microprocessor processes. Second one, the number of words that the microprocessor can address. So greater the number of words that the microprocessor can address, greater will be the reachability of that microprocessor. And the third is the speed at which the microprocessor can execute an instruction. So greater the speed, greater will be the number of instructions that will be executed by the microprocessor. So these are the three important measures on which the power or the capability of the microprocessor depends on. So this is a very simple diagrammatic representation that represents the various factors on which power of the microprocessor depends on. That is the word size, the number of words, and the speed. Now, let us discuss something about microprocessor-based system with bus architecture. Now, here, this is a very simple schematic representation of how a microprocessor interacts with the other devices that are associated with that are associated or present in the microcomputer. Now, a microprocessor has in it arithmetical logical unit. It has in it register array. It has in it control unit. Now, arithmetic logical unit is capable of performing arithmetic logical operations. Control unit is capable of generating control signal that is capable of controlling and coordinating the activities of other units. Register array is capable of hosting operands whenever the arithmetic logical unit performs operation. Likewise, system bus is a communication channel that is established between the microprocessor and the other peripheral devices that allows the microprocessor to interact with them. So let us start with the description of the various units. So arithmetical logical unit. So arithmetical logical unit is a unit that performs arithmetic and logical operations. So arithmetic operations such as addition, subtraction, multiplication, division, and logical operations such as realization of AND gate, OR gate, NOT gate, XOR gate. So different microprocessor has different set of instructions that enables different arithmetic and logical operations. Now the operations are performed using operands that are stored in the register or that are stored in the memory. Now register array. And now register array, it consists of various registers identified by letters such as B, C, D, E, H, L. There can be a 8-bit register or 16-bit register. So in order to create a 16-bit register, so what we need to do is we need to create register pair like B, C, D, E, H, L. Now these registers can be used in order to store data, or it can be used in order to store address temporarily during the execution of the program. Now the next unit that we have is control unit. Now the control unit provides all the necessary timing signals and timing and control signals to facilitate the operation of the microcomputer. It controls the flow of data between the microprocessor and memory and the peripheral devices. So all the coordination and the control activities executed by the control unit. Likewise, we have input unit. So input unit is responsible for transferring data bytes and instruction byte from the environment to the microprocessor. It includes devices such as switches, scanners, and analog to digital converters. Likewise, what we have is we have output unit. So output unit is capable of transferring data bytes or output from the microprocessor to the environment back. So, for an example, you have printers, magnetic tape, and other devices. We have memory unit. So memory unit is capable of storing binary information pertaining to instruction and data that the microprocessor uses whenever it performs operation. So in order to execute a program, the microprocessor has to read the instruction as we have discussed in the previous class. So we have instruction fetch, instruction decode, operand fetch, operand execute, and then operand store. So these are the operations. So these are the activities that are performed whenever a microprocessor has to execute an instruction. So in order to execute a program, the microprocessor reads the instruction and the data from the memory, and it performs computation operation in its ALU section. The results from the operations that the microprocessor performs can be stored in the memory or can be sent to the output section for display. Likewise, we have system bus. So system bus is a communication channel or communication path that is established in between the microprocessor and the peripheral device. The microprocessor at a time can communicate only with one peripheral device, and the coordination activity is performed by the control unit. So this is a brief discussion about the various units that a microprocessor based system has in it. So in today's class, what we have learned about is we have learned about in brief the components of a microprocessor. We have learned about different types of microprocessor applications. We have learned about microprocessor and its relation with microcomputer. We have learned about the various measures that governs the capability and or the power of the microprocessor. We have learned about microprocessor based system and the allied bus ARM architecture. So in the next class, what we're going to do is we're going to start with 8085 microprocessor, where we will be discussing 8085 architecture. Thank you very much. Good evening.